Yeah, the day of birth, right? It's really hard to predict, isn't it? I guess if you were really trying to plan things out, you would work for conception 9 months before the birthday. Yeah,
Yeah, that's tricky. Yep.
that would be too tricky. Plus, there's all kind. Yeah, that's just yeah, awesome. Uh, is everyone happy with that being independent? Okay, so have you all started number two? That's a no. Cindy, you're muted. Nice.
No, they haven't. So I think you should give them some time and let them work to number two.
Let's do it. So let's do 5 minutes. Here, let me highlight a few things, and just to get your brains going, just to make sure I'm doing something. Does everyone remember what fair? Oh, that's the first question. You know what? I'll just be quiet. Set a timer for 5 minutes. Okay, y'all. How we feeling on this? Anyone have a feeling about what it means to be fair? Or has that question got old yet? Equally likely chances. Nailed it, Emily. Love it. Just so we're clear, equally likely, what is the chance of any one number appearing when we roll the dice? Anyone know that probability? Roll that 20-sided die. Note, I didn't say when we roll it 3 times, I just said when we roll it once. Do we know what these chances are? And to help, I'm basically asking what's the probability 1 occurs? Ooh, good. Is this a good thing to review, or are we just quiet? Do we have no? It's totally cool if you have no clue.
I think they're very, very quiet today.
Is it one of those? I'm with y'all. So my 5-year-old, here's why I was late. My 5-year-old, when she was dropped off at 6:30 this morning, said, "I don't feel good." And then, as we were driving to school, she got chatty, of course, which means she feels fine. Little scam artist. So I'm like, "You have to take a nap, or you're going to school." "But Daddy, I just want to play." "You take a nap, or you're going to school." And so then finally at 10:45, she says, "I want to go to school." So I drove her to school, which made me 10 minutes late. How does it make you all feel? Great story. Glad we recorded that. Does everyone feel really good about 1? Let's change the number from 1 because maybe that's confused. Maybe that will hide what we're really asking. What's the probability that we roll a 3 when we roll this 20-sided die? And since there's 1 3 on the die and there's 20 numbers on the die, we know that's going to be 1 out of 20. So when you said, "Hey, they're equally likely chances," nailed it, Emily. We know that the equally likely chance is exactly 120. And we might need this when we roll this crazy die 3 times. So, first, we should ask ourselves the same question you were asked up here. When we roll this die, is each roll independent of the next roll? Nice, Laura. Yeah, because there's when you roll the die, you don't like break off a side of the die and you now have 19 numbers left, right? Each time you pick it up, you roll it, there's a 1 in 20 chance any one of those numbers pops up. This, by the way, is why when you go to the casino, I know I've said this already, but I'm saying it again. When they say you're looking at the roulette wheel and they post the last 5 winning numbers, this is why that's worthless information, because those numbers weren't taken off the board to change the probabilities. Your chances of winning are still, you're not going to win every single time, no matter what has happened the previous 1,000 rolls. Okay, wasn't that fun? So this one, we're going to look at first. Notice the language of sequencing. First this happens, then this happens, and then this happens. If I were to write this symbolically, I would be saying the probability of a 20 and a 1 and, are we okay with, let's just do number greater than 15. Now, remember last time we talked, when you saw the word and, it was a thing you were subtracting from a sum, right? We looked at, are these things disjoint or not, these events? And if they weren't disjoint, we had to select or subtract the overlap. That was when we were doing one thing. We rolled the dice once and we wanted to get a 20 and a number greater than 15. There you added the chance of a 20 plus the chance of a number greater than 15 and subtracted the overlap. Here, what's different is we are rolling the die 3 times. So we're kind of doing this experiment. No, the experiment is rolling it 3 times, but we're doing 3 different things. And we're wanting the first thing to be the 20, then the 1, then the number greater than 15. Because it is that sequence, we multiply these because they're independent. How do y'all feel about that subtle difference from what we're doing now compared to what we did before?
I feel pretty good about it. We did it last night in class, and I learned that if I turned my or my phone sideways, that there was a whole bunch more buttons I could use. I didn't know that. That was really exciting for me.
That is an exciting thing. And throw that phone away because those calculators are garbage. I'm just kidding. That's wonderful. How do we feel about this as our answer? And then I'll type that in Desmos, and hopefully you will love Desmos. 1 divided by 20 times 1 divided by 20 times 5 divided by 20. There's our answer. That's what I like about Desmos is you can see the fractions typed in, so you know you won't mess it up. With your sideways calculator, it still doesn't do it like that.
They still loved it though, Eric. I hate to
Okay.
tell you.
That's okay. Love it.
I was trying to show them like so many different ways, and I said, okay, so you guys, we got Desmos, we got the TI-84 because some of them have it, and then I'm like, okay, worst comes to worst, turn your Laura just about jaw dropped to the floor. She loved it, and I said, you know what? If this works for you, then this works for you.
Agreed. If that works, make it happen. Okay, so do you all just want to tell me the answers for C and D? Maybe I'm like talking way too much and you already knew this. I was just filling the silence, and that's sometimes silence doesn't need to be filled. What was your answer to C? Okay, how many numbers are greater than 17? That was, in my head, 18, 19, 20. 3 numbers are greater than 17. We're going to do that 3 times. So this should be 3 over 20 times 3 over 20 times 3 over 20. You should be thinking first roll 1, roll 2, roll 3. We want to know the chance that it happened in that order. This is also why gambling means you're going to lose every single time, because the chance you won on this gamble is what, 0? By the way, if you like exponents, which is helpful, I think sometimes for writing stuff faster, you could do 3 over 20 cubed. And that's 9 over 8,000 if you want to think of it that way, or whatever you want to do is cool. Whatever works. Oops, too many parentheses. I get, oh yeah, you got a 0% chance of winning. That's wonderful. 0.003375. Is that what you all got? This last one is the one that's super challenging, but maybe you all feel good. My in-person folks had a time with this one.
Eric, can I tell you that I gave them a different formula?
Oh, let's do it.
And they loved it. Okay, so what we did, it's not much different than the formula you use, but you don't have to do that 2-step thing where you have to subtract and find the 0, whatever. So the formula is 1 minus, and then parentheses, 1 minus the probability of the event
Nice.
raised to the nth power.
Nice.
So you don't,
Yes.
because it has the complement in it.
Right.
So they all thought this was amazing. They didn't have any issues at all.
I'll try that tomorrow with my in-person folk and see if they feel good. Yeah.
Yeah, the
That's wonderful.
other way is really confusing.
Yeah,
You
love
have
it.
to go off to the side and find the
Yeah,
complement,
you
put
gotta
it
find
in. Yeah,
this, which is exactly what this is. I mean, these two are the
it
exact same
is.
thing. So yeah, love it. Love it. Okay, so you all have this answer then. This is 1 minus 1 minus 1 over 20 raised to the third power. Is that what you all have?
I hope.
We'll assume it's so. So 14, 26, 25. Cool. Good. That's wonderful.
Why are you putting that to the third power when it says that you roll at least 120 and it's not telling you how many to roll?
Great. It's kind of a
Okay.
bad setup for the question because here it's in there, right? But it was up here that we said,
Right.
oh, you're gonna roll it
Okay.
3 times. So yes, that happens a lot with these kinds of problems that in the prompt we tell you, or we tell you somewhere like, hey, you're gonna do this 4 times, and then it's part A, B, C, D, E, and F off of that 4 times. So good, Laura. I'm glad you pointed that out and made that question because it's a common, it's like a misleading thing. It should just say, what is the probability that you roll at least 120 on your 3 rolls or in your 3 rolls or whatever? Good. Okay.
The only thing I see with that, Eric, is it does say to give 4 decimal places.
Oh, yep.
Not that that's a huge thing, but if it was in my stat lab, it would be.
Yes, it is an important thing. I should read. We'll do it in pretty pink. I will be very picky about that on the exam. I think. Probably not. Okay.
I really don't believe you.
Yeah, I won't be picky about that. I might take off a half point off of the entire exam if you do it a lot. One of the reasons, or one of the places where this is why we want this, is if you are using the numbers later, and I want to know that we all get the same numbers to make it easier for me to grade. But that might just be laziness on my part, right? So I don't have to do calculations every time I grade something. So like in chapter 4, when you write down the equation of the model, it would be nice if we all had the same decimal places. So then when you plug in a number, we all get the same number and I can quickly check if you did that right or not. Okay, so number 3, I want you to notice something here that got my day student or my in-person students. We've given you probabilities here. All the other problems we've done have been frequencies. Like if we go back to this 5.2 worksheet number something. Yeah, here we had a bunch of frequencies, right? That's, and you had to calculate all the probabilities. So what's happened in this table down below is we've actually taken each of these numbers and divided it by this and just written it as a probability. So we've done some of the work for you, is my point. So be careful, you don't need to do any dividing of things. You've got the probabilities, just do your mess with those probabilities. Let's do number 1 together, or letter A together, just because it's kind of, this is always a question. So we've got this frequency distribution, and it's the number of tests conducted at some emergency room for patients that show up at the emergency room. So if you think about what's happening here, you're coughing, throwing up blood, you got diarrhea, whatever, and you go to the emergency room because you're dehydrated. and they get you an IV of liquids, and then they're like, we need to figure out what's going on here to see if we need to admit you or not. So the doctor says we need to do a blood test for something, I don't know. So that would be one test. And then they're like, oh, that came back showing us nothing. Now we need to do a urine test. I don't know. So that now we've done a second test. So this says, why is it safe to assume the number of tests administered or performed on each patient is disjoint? Well, if 0 tests are ordered, that's the number of tests that were ordered for you. But then if they order 1 test, that's the number. You can't have a doctor order no tests and 1 tests on you at the same time, right? Does that make sense? It's like you can't buy 1 car and 2 cars at the same time. Either you bought 1 or you bought 2. There's no overlap there. And if you bought 1 car and then you also bought 2 cars, now you actually have purchased 3 cars. So you can't have overlap. Yeah. Okay. So that's that one. Have fun writing that one down. I'm not going to write anything for you. I'm going to make you write it. And then please pay really close attention to this, and this, right? So this is a mix of 5-2 and 5-3 in the same question. All right, taste it for like 5 minutes, and then I'll see where you're at. Set a timer for 5 minutes. few more minutes. You stuck? You there? Did you? Yeah. I'll just highlight some more words for fun. I'll give 2 more minutes and then I'll demand feedback. Set a timer for 2 minutes. All right, that was 2 minutes. Where are we at? Who knows the answer for B? The probability of selecting one patient that did not have exactly 4 tests performed.
How dare they mix or section 5.2 to 5.3?
Yeah, right.
Gotta do it.
This is for you all. Oh, the places you will go in statistics. Did you all say, I know I'm caving, 1 minus 0.093? Did anyone do that? Okay, Laura, nice. Did anyone add up all the other ones? Just totally fine too if you did that. Let's see, this feels like 0.907. Yeah. Yeah.
Mhm.
It was just one person.
You should know, you're the one with the master's degree.
Ooh, burn. Ouch.
Ooh.
Ouch. Yes, yes. I do know this answer. I did it just yesterday, I think. Okay, good. So let me ask you a different question. When it says at least one, what are the outcomes in the at least one event? So I'm not asking for the probability. Of these numbers here, which ones fall under the definition of at least one?
Would it be the 0 and the 1s?
Is 0 at least one?
No, so it would be just 1.
Is 2 at least one?
No.
Hmm.
Why?
Is it at least one? At least.
Oh, okay. Yes. I'm thinking 1 or less.
That would be
So, yeah,
at
the 1
most
through
one.
5.
We're going to get to that language in chapter 6. The
Good,
word at
LaShawn.
most, yes, versus at least. So at least means like, oh, I've got at least 10 pens in my hand, right? I could count them and see that I have 20, and I was still correct in my statement that I had at least 10, but there's actually 20. So when we say at least, that's one of the things that can make this super tricky. Yeah, LaShawn crushed it. It's 1, 2, 3, 4, and 5. It's those outcomes. Do you see the complement of those 4 out, 1, 2, 3, those 5 outcomes? Y'all see it? If at least one are the
Couldn't you
numbers.
take the 1, subtract the 0.33?
Yeah, because 0 is the complement of at least one.
Right.
Now notice we
Okay,
only
then I
picked
did it
one
right.
patient. You did do it right. I'm trying to get you all to see why at least one uses complements. Because when you look at the at least one part, here's the at least ones, here's the not at least one. That's why that formula we wrote down back here works. Right? This is literally what's happening. Okay, so what is this? Point 677, is that what that is?
667.
667, yeah. Arithmetic, yeah. Awesome. Okay. Hey, why are these things independent? Why is it independent, that each patient would be an independent deal from each other? What did you all say?
Laura, think about what we said last night.
Because no 2 patients would have the same test, because not everybody comes in with the same issue. So there's no telling, like, I could have 3 tests and you could have 1.
Yep. Patients are coming in for different medical problems. So there's no way that we're gonna, there's no way that what your tests are gonna determine what the next patient's tests are order. It's based on you. Patients have medical issues, different medical issues. The only way this might not be true is if it's like it's a profit thing where they like order tons of tests just to make money. I feel like back when, well, I'm not going to say that. Here's one. I took my cat in because I thought he was constipated, and I dropped him off, and I just signed a thing that said you can order tests without calling me, and they ordered 3 blood tests, 2 of them crazy expensive, and they're like, yeah, he's fine. I'm like, what? Okay, so why does independence matter when working with multiple selections in a row? First this, then this. Why do we have to be concerned with that?
Because the numbers are different.
Which numbers are different? I love that.
Like selecting 2 patients at random, the probability that, well, ask your question again. Hold on. I slept for 2 hours last night. Okay. Try me one more time. I
That's-
had the answer.
That's good sleep. That's why are we concerned about independence when selecting items in a row, more than one item, like first this, then this, then this? Why is it we have to think about independence?
Because they're not always the same. So it's one, one, and sometimes they are the same, but you don't know until you take that sample.
I like what you're thinking. And from what I'm hearing is you're talking about the individual probabilities for each selection might be different. What do we do with those probabilities to calculate the whole thing happening? What operation?
Multiply.
Nailed it. Independence goes with multiplication.
Yay.
Disjoint. Yeah, feel good. That's two hours of sleep. Disjoint goes with addition. Disjoint goes with one thing happening. Independence goes with that should say multiply. Multiple things happening. Let's not say that. Let's say sequencing or time frame. We'll just say sequence. All right. So the other word that goes with this is and, goes with the independence and multiplication and sequence. The word that goes with addition is or primarily, but if they're not disjoint, then you have the word and it's a different and than the independent and. Right? Yeah.
Yeah, they loved that last night.
Isn't that wonderful? But how do you tell a difference? You read the problem and ask yourself, are we selecting multiple things in a row? First this, then this, then this. That and is a multiplication and. Are we selecting one thing and piling on a bunch of criteria that thing could be? That and is an overlap and it's the thing you subtract.
They also noticed last night the and that meant to multiply. Most of the time it said with replacement or it said it was independent. So there was a huge clue because of saying it was independent or
Good.
with replacement that it meant to multiply.
Good. We used to teach what you had to do if they weren't independent, meaning they were dependent. That's no longer in the course right now. So that's nice because that adds another layer of craziness. But yeah, that's yes. With replacement means independent. Okay, so more than three, that's this. Add those together and then multiply that product times each other, right? Oh, fail. Why am I wrong when I included 3 in that? Does more than 3 mean include 3? Oh, I gotta let my dog back in before she runs the neighborhood and dies. Though that wouldn't be too terrible, would it?
Eric, terrible.
I don't want her. She's a pain.
No, more than 3 is just 4 or 5. Now, if Eric's dog really got hit by a car, would he feel terrible?
I would feel terrible. Anyone want this little thing? Look at her. Isn't she
I will
such
awful. Take her in a heartbeat.
Sophia? She's a Shih Tzu Dachshund or something. I can't get rid of her. My daughters would
I have a
throw
Shih
me
Tzu.
out.
I have a Shih Tzu Yorkie, so
Oh, yours is probably better.
I
She's
have a
such
Shih
a
Tzu
sweet
Terrier.
Oh, okay. Maybe yours is even better. All right. So what did you all say? Should we include
I got it.
or should we not? Let's see yours, Cindy's. Who's cuter? Who wins the cuteness?
Oh,
award?
I gotta put my I have that stupid background thing on.
Oh, it won't pick up a dog, will it?
It won't pick up a dog. I'll put her up in a minute. She's mad.
Okay, I'm gonna answer my question because I'm pulling teeth here and it's difficult. It's just these two because more than 3 is not larger than 3. So what we're doing is we're adding these two together. So that's the probability of 1. and we're doing 2. So really, if I were to write this out, it would be the probability the first patient is more than 3 and the second patient is more than 3. So what is this? My brain isn't quite arithmetic today, so I can't do that in my head. I should be able to. There you go. I knew that, right? So the first one is 0.223 and the second one is 0.223. For the first patient selection, they're independent of the second one, so we can multiply. There's our thing. Calculator do I have open? So 0.049729, 0.049729. Now, were we told how many decimal places to write anywhere? We should check that. How's Stat Lab going for all this? Give 4. 1, 2, 3, 4. Shoot. I recall that Stat Lab for this set of problems can be difficult. So I hope you're tasting and enjoying.
Where are you getting the 0.223? I
Great
must
question.
have messed up.
We're to calculate the probability that they had more than 3 tests done. So the number of tests we're looking at is 4 and 5. So I added 0.093 to 0.130, and that's the chance that they had 4 or 5 tests added. Is that okay?
So Laura, I think last night you were using the exponent, like, so you did 0.223 squared.
Is that helpful? Awesome. Okay, and then the one that we liked, we have at least one of them had 2 tests done. So that was that 1 minus the probability of 2 tests. Well, 2 tests is 0.148. Fail, I missed the 1. And then we're doing 4 of these. So we're selecting a person and selecting a person and selecting and selecting. Nailed it. So we raise it to the 4th power. Love it. That's going to be some sort of number. I have no clue what that is. But my calculator does. And we just need 4 decimals, so 0.4731. How do we feel about that? Those of you that are here and participating, are you feeling like you're learning things, or is it working, or do we need to talk about things? Anything confusing? All right, well, let's keep going. Try this one. I think, yeah. Let's do this one, and then we'll have some time to do the first page. So there's some adding here, gross, whatever. I know the answer here is 1, but you'll want to add these up to get the positive. So if you look down here, when you see A plus, this column is the plus column, this column is the minus column. So right, this cell would be O negative. You'll be reading these exact things in your nursing program when you all get in there. So you now know how they're constructed. Okay, I'm going to be quiet. I'm going to give you 5 minutes to set it up and see if you can't at least get up through E. So the timer for 5 minutes. Well, that was 5 minutes. Let me ask you this question. How do we all feel about blood type being disjoint? Can you have type A positive blood and type B negative blood, excuse me, at the same time? Unless you have two circulatory systems that are in complete isolation of each other, that's not going to happen, right? So blood types are disjoint. You can only have one type of blood type. That's why I'm allowed to add things in D. Did you all get 0.375? I should ask, do you all agree with my numbers here? Because if we don't agree there, then you know, we got none of our answers below will be right. Oh, 3 decimal places. Is there any overlap in E? Is there any part of A and positive blood that is not disjoint? Are those two events not disjoint, or are they disjoint? I guess is my question. I'll show you why they are not disjoint. I had good wait time there, didn't I? Here's the A part. Come on now. Oh, this dumb thing. Here's A. Here is positive. Do you see any overlap between those two lines? Yeah, nice. So right inside here is overlap. So when we do this calculation, we can't just take the 0.42 and add to it the 0.85. In fact, if you did that calculation, you should have been like, wait, I might be missing something, because when you add those two numbers together, you get a probability greater than 1, which can't happen. And that's because there was an overlap. A and positive have the overlap of A positive, so we got to subtract that 0.36. These two are not disjoint. And so, okay, why is this here? I don't know what that is. So we get 0.91.
So Eric, I think you mentioned on Monday when we did one, anytime you have a row and a column, that you will have not disjoint.
Yep. Yep, from these two-way contingency table, that's 100% right. It's always going to happen when you're doing rows and columns, because there'll be overlap. I am remembering, and Cindy, I didn't tell you this, I am gone Sunday, Monday, Tuesday of next week to
the conference.
Yes. Okay. Did I tell you that?
No, but I know that like Allison was asking for people to sub, so I figured it was it was a conference.
Yeah, this is I'm going to another school to figure out how they tackle diversity issues as this committee at mine. So we're going to figure out how to tackle diversity stuff at Jackson College. I might be able to do Monday night, although we might be going to a restaurant between the hours of 6 and 8.
It's fine. I can do it.
You're good. Okay, I'll see what I can if I can pop in. Maybe if you're going to do it, you should use your Zoom. Although that
Yeah,
might
no,
be
yeah,
easy for
I
them.
need to use my Zoom so that I can
You can
record.
have control and record. Yeah.
Yeah, I wouldn't be able to record.
Let me send that announcement out. Sounds like I'm going to do that. And
So yeah, it'd just be Monday.
just Monday, yeah. And I can pop in. I think I can pop in on my phone. I take a little bathroom break or something, and pop in real quick and say if anyone's on this Zoom and say, "Hey, go to Cindy's."
Yeah.
Cool. Okay. Did everyone get these right? Or okay, Laura, I'm going to take you as everyone. Now, well, you're the only one responding right now, which is totally fine. But I just don't want to move past things. Notice this: 3 people, and that goes for all of these. So this question, like the last one, Laura, it doesn't make it clear that it's 3, but it is 3. Whereas these 2, it's pretty obvious 3. You're fine, Emily. You all don't need to respond. It's okay. I just don't want to fly on if someone has questions. So maybe just interrupt me. I'll have my wait. That's why I use my phone as like wait time.
So that 3 people would be like the n equals 3.
Nailed it. This is n equals 3. We really only need it down here.
Right.
But here, like if we say type B blood, right? That's what, 0.03? Ooh, that's a rare type. And we're just going to cube that because it's 3 people. 0.03 times 0.03 times 0.03. What is that? 0.0027? Does that seem right? No. Should there be a third 0? I don't know. 0.03 times 0.03 times 0.03. There should be 4 zeros. 1, 2, 3, 4. And if we're doing it to the, seriously, if we're doing it to the 4th decimal, the answer here is 0. Do y'all see that? If we're giving 4 decimal places, that would be 0.0000.
Shouldn't we? Yeah, I was just gonna say, shouldn't we be using 0.09? You're using AB blood instead of B.
Yeah, that would help.
Good catch there, Kayla.
Thank you. So 9 to the 3rd power. I don't know what that is. 9 times 9 times 9. There we go. So that's 729. So there, at least we get a 0.00.
Take 1 out. I think it's 0.00729.
Oh. It seems like there's a really good song for this about it's like one of those days or something. I don't know. Okay, so 3 zeros, 0.000729, which rounded to the 4th decimal place is 0.0007. There we go. Cool. Okay, so then O plus A plus B plus. O plus A plus B plus. It's those 3. Be careful. They're not disjoint outcomes that we're selecting one and wondering if they're one of those 3 blood types. It's 3 individual people being selected in order. First one, then the next, and the next. So this is the product of those 3 things. 0.39, 0.36, oops, and 0.075. Whatever
So you guys,
that
you can see your hidden, remember we talked about the hidden and words like 1st, 2nd, 3rd, and they are on your exam note pack or at the bottom of the page we looked at. like first, second, third, fourth. Those mean to add or multiply.
Any sequencing is multiplication. Okay, and then we got our fun one that Laura, you said you probably all are probably all stars on this one. 1 minus the probability of O negative is 0.07. And we're selecting 3 people. So we're going to cube that, and whatever that is our answer. Oops. What am I sharing? Can you?
We can see, well, we could.
There we go. I thought I was sharing like my entire screen. Yeah, we'll just fix this one. Oh, we'll do this one. 0.070. So 0.1956. Okay. Good. Do we feel happy about this? Are you ready for the midterm? Let's look at how this might show up on a midterm. So if we all go to, come on, the sample midterm exam. I'm not going to do any of these problems yet because I want you to take this as an exam. This is more questions than what will be on the actual midterm, but it's the types of questions that will be there. And you'll see these are all the same questions as from the worksheets and the notes. What I want you to see is where these probability things will show up, so that you will know that the questions we just did are essentially the probability questions you're going to do on the midterm. So not this one. This is the 5-2 one, although that does have some disjoint and not disjoint stuff in there. But here's an example sample midterm one. Notice instead of it being probabilities, it's frequencies. So you're going to have to divide in, you're going to have to add numbers and then divide by a total. So this is a similar question like what we just did. Here's your favorite, a tree diagram that you may be asked to draw. And here's a question like what we just did. That's a lot of probability on there. Man, I forgot about how much probability there could be on there. So these 3 pages are the practice problems that the exam will look like. And I really, really want to drive home the point that if you have done all of the worksheets that we've been doing in class, plus the sample midterm, plus the review ones we've been doing, you will have done every problem on the exam. There will be no surprises. The difference is like that one table, instead of number of tests, it was hours of sleep. So the context will be different. And maybe we'll select 5 patients and 20 patients, and it'll be at least 1 or less than 7 or something like that. But it's all going to be the questions you have done in class. So your job is to figure out which ones do you know how to do and which ones do you don't, as prep for the actual midterm. Let's see. I'm going to jump into Canvas, and we're going to look at which review sheet is labeled in there for you to do. I believe it's both 1 and 2. And I think it might be worth doing both.
I think it definitely is worth doing both.
Yeah, so let's do them. But I just want to make sure I don't screw up what is listed in here and what Cindy sent out. So based on what I'm seeing in Canvas, we are scheduled to do worksheet 1 and worksheet 1, worksheet 2, and of course the sample midterm, which is part of your midterm grade. Remember that you get 20% of your midterm is how you did on this sample midterm. So
Eric, can you pull back up to 6.1 worksheet number 3? So that worksheet is not in their course pack. So, and that's what I would be doing with them on Monday. So do you want me to just...
Should we do 2? Or is that the one
I'm
you're
doing two, I'm doing two.
Should we do one?
I can do that,
Or
or
should we delete it?
it doesn't matter.
Let's delete it.
I'm doing, why don't you take out, because I'm doing 6.1 worksheet 2.
Choop. And then you could.
I mean,
we
I
could-
can do one, or
we could do the review. It's the same stuff, right? 6.1 is 6.1 is the stat crunch stuff.
yeah, it's all Stack Crunch stuff. I can do
So-
6.11 if you want. It's whatever you want me to do. I mean, that's a decent one. Whatever you want me to do.
I think there'll be enough between the review and the 6.1.2, unless you think we should do more.
Nope.
Let's do that. So I'm going to delete it right now so that people feel good about it not being there.
Yeah, because it's not there. I mean, they can't get it.
Right. Right.
I looked and I don't have it.
Alana did send out an email that said,
Yeah, but it wasn't attached.
oh, right. It's in her drive, and I could,
Oh, yeah, I forgot about that.
you know. Okay. So what you're doing now is we're going to start with the chapter 5 review 1. Which is page 564. See if you can't draw that tree diagram and use it to list the sample space. And let me make sure I delete it from this other class. Page 21, worksheet 2. There you are. Delete. You'd think I'd learn. And I don't, sometimes Canvas, like, what did I delete? 6.1.
6.1 worksheet 3 you need to delete. Well, yeah.
I don't know what happened. I deleted something else in here, I think. I don't know. Whatever, this looks good. I think we got it.
Yeah, I think you did 6.1 worksheet 2, which I have in mind, so it's good.
Okay, I think we're good. All right, did we do 5 minutes? See if you can't do all of problem 1 for 5 minutes. Set a timer for 5 minutes. I'm going to draw the tree. That was 5 minutes. I'm just going to draw the tree, and then you see if you've got the same thing. Actually, first question. Did you all start with the even versus odd, or did you start with the hearts, spades, diamonds, or clubs? Evens, odds first? Doesn't matter. I'll do evens and odds. So there I have rolled the die. Then I'm going to pick a card. There's my list. Just to check that everything matches with my multiplication, I'm going to do 2 times 4, 2 ways. The first thing can occur, 4 ways the second can occur. We should have a total of 8 outcomes in our sample space. So I'll call that as S. So even H, even S, even D. That's the first set. Shoop, 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 shoop. Second set. Does this look like we all had? Yay. That's everything. Now, this says explain what it means in English with context. What'd you all say?
Probability of getting an odd club.
Nice. Probability, rolling odd, drawing club. This is a weird situation because there isn't a sequence here. We're not really talking about, well, you know what? We could think of it that way. That's the unfortunate thing. You can do it that way. What do we know about these outcomes? Are they equally likely? And the answer is yes, they're equally likely, because each of these outcomes are equally likely. So this is a 1 in 3 and a 1 in 3, no, a 3 out of 6 and a 3 out of 6, and these are a 4 out of 8 and a 1 out of 8 or 1 out of 4 for each. So we can treat these each as a 1 out of 8 chance of happening. So our answer here is just 1/8. We could turn it into a sequence, and we could say the probability of odd is 1/2. The probability of clubs is 1/4. And so if we thought about it as sequence, we would be thinking about this. They're independent events. So it would be the probability of odd times the probability of clubs, which would be 1/2 times 1/4, which is 1/8. So it does work either way. And this is only true because these are equally likely. Right? And then look at the language we use here. And then first this and then that. Ooh, okay, how many red cards are there? Well, hearts are red and diamonds are red. So it's a 2 in 4 chance here and a 2 in 4 chance here. So it's really a 4 out of 8 up here for hearts for red. Oh man. So odd is 1/2. Red is 1/2. So our answer is 1/4. Talk to me, y'all. Yeah, we're okay. Okay. All right. That's tricky because we can approach this one in a bunch of different ways. We could have looked at ooh. Yeah, well, could have looked at it different ways. Okay, then try number 2. Let's do another 5 minutes. Now, let's make sure you get what's going on here. These numbers are kind of ridiculous. It's the numbers in thousands of earned degrees by level in 2 different fields, conferred in the US in a recent year. Conferred is the word for we handed you the degree and now you have it. So don't be bothered by these decimals up here. That just means 154,900 bachelor's degrees in natural science. So the totals, 444 point, you can use these in a decimal form. And this is going to be your divisor. That's the total of everything out here. Okay, so let me just let you do it. Set a timer for 5 minutes. More time? Less time? How about 3 minutes? Set a timer for 3 minutes. How about you all tell me when you have either stopped being productive or completed it? Or 3 minutes, whichever comes first. Ready. Okay, Laura, you're ready. Okay. Well, let's do it then. Okay, so you know, I sometimes don't like when we do this because note we're selecting a person, meaning one, and we're finding the probability. Then we're giving 3 decimal places. So earned a degree in natural science, that's the 199.1. That's the total natural science degrees over 447.4. Whatever that is our answer. I'm getting 0.445. Nice. Earned a bachelor's degree or a master's degree. Note the word or here, meaning we're going to add together these amounts or these individual probabilities, either way. And so anytime you see or, you have to ask yourself, are these options, are these events disjoint? And because they're rows, they are disjoint. So we're doing 319.2 plus 100.1. Now, do you all add, have you been adding the totals together and then dividing by everything? Or have you been writing it individually like this? Because it doesn't matter, they're both the same thing. So you could think of it like that, or you could think of it like this. Okay, let me get my pad straight. Is there any one of those things?
I've shown both ways, Eric, and some like the first, some like the second. So
this is just like the definition of fraction addition is essentially what it is. So whichever one you like better is fine. You can, however you put them together. If you're using this old garbage calculator, I mean, this nice little phone calculator, it might be easier with the second one because you add together the two numbers and then divide that. Otherwise, you might get it wrong in the other route. So I got 0.97937. Awesome. Those are disjoint. Life was good. Now we're looking at doctor's degree. Oops. Here's the word and. Is this the multiplication and, or is this a both things must be the same, must be true and? And so the answer to that is we're looking for selecting a person that has both a doctor's degree or that has a doctor's degree in natural science. In other words, we're looking at an intersection of things. These are not disjoint outcomes. It's a column and a row. And because the word and is there, we're selecting all of the people who have the two things at once. Notice the other thing to remember is we were only selecting one person. That's why this is the 16,000 divided by the 447,400. Yeah, no, maybe. .036. So now, so we should note here that what we had to think about is these were not disjoint outcomes. By the way, if they were disjoint outcomes, this would have been 0. Because when you asked for disjoint things in an and, there is no overlap, so that probability is 0. Whereas now, look, we're doing an or, and again, these are not disjoint. We have a master's degree with computer science. So here's the overlap. So 2 ways I think maybe the way you like most is writing it all out. Is that correct? With this one, maybe it's easier to write it all out. So that's the master's degree, 100. The computer science is 248.3. There's one of those guaranteed jobs. Everyone needs a computer scientist, minus the overlap, the ones that were counted twice. And just by our definition of fraction arithmetic, we can write this as doing the arithmetic in the top and then dividing that result by the number in the bottom. So that's the rules we adopted for doing fractional work. Whoops. So there's really this many unique items that meet the criteria, and we get 0.618. Oh, thanks, Laura. Crushing it. 0.618. Good. Ooh, did not, right? We're just testing, do you get what it means to be not? Not a bachelor's, so we could either add these two together, which in this case isn't too hard, right? 128.2, or we could do 319.2 divided by this, subtracted from 1, which I think I'll do that one, just to remind you of not means the complement and how you can use that as a shortcut in your calculations if you so choose. Of course, it's not as fun with this. So 319.2 divided by 447.4 is that. Subtract that from 1 and we get this, 0.287. Remind me, what does it mean to be unusual? Because I've forgotten. It's been too long.
That more than 5% or less than 5% or more than 2 standard deviations away
Love it.
from the mean.
From the mean. Right. So the second one is useless here, right? Because we don't know standard deviations. You're crushing it, Laura. So 2 standard deviations away from the mean. It's good to keep track of both. You're going to be asked to use both definitions on the midterm. When we're talking about z-scores, you're going to have to use the second one because z-scores are standard deviations. When we're talking about probabilities, you're going to use this one. So what? You agreed that this is the C because 0.036 is less than 0.05, right? That was our unusual result. I don't think there's any others. No, those are the only 2. So earning a master's degree in computer science, wrong. Earning a doctorate degree in natural science is uncommon. And if you look at the totals of those, it would also be uncommon or unusual to get a doctorate in computer science. Okay, so note here we have frequencies and we had to do division to calculate our probabilities. Check out this table. You're given the outcomes and you're given the probabilities. We don't know the frequencies. So let's do 5 minutes. Do we have time to do that? Yeah, let's give you 5 minutes to just attempt A through D, and let's just see where you get. And then we'll take the last 5 minutes of class to talk about that and what's happening in the future. Set a timer for 5 minutes. All right, that was 5 minutes. What are the 2 criteria for a valid probability model? Each probability between 0 and 1. The sum of all the probabilities equal to 1. I'm going to say there's like a 99.99% chance you're going to have to tell me that on a midterm. I'm going to say, here's a model. Is it valid? Or what has to be true about this model for this to work? And it's those 2 things, both of them. We could check it. It works out. Odd number of dogs. Let's see, 0, 3, 5. Is it true that these outcomes are disjoint? Can you have 1 dog and 2 dogs at the same time? No, you can't, Laura. You can't have 1 and 2 dogs. Well, I guess if you're babysitting someone, oh, okay, but that's 3. That's not 2 or 1, right? I guess if you were watching someone else's dog, you could say, well, 2 of these dogs are mine, and 1 of them is someone else's, so I have 1 and 2 dogs at the same time. But the point is, you can't have multiple amounts of dogs at your house at the same time. Either you have 1 or 2 or 3 or whatever. So these are disjoint, which means if we're randomly selecting a household, if we're just grabbing one household out, are all of those one household selections are disjoint. So what's the probability of odd? We would add these 3 together. Is that what you all did? Did you think to add? Awesome. Oh, I answered this question. They have to be disjoint in order for us to add. So like I said before, when you think about disjointness, you're thinking about addition. You're selecting one thing and having multiple options of what that one thing could be. Hey, what's the probability we don't have 4 dogs? Yeah, that's 1 minus 0.021, right? Here's the 4 dogs. The complement of not having 4 dogs is having 0, 1, 2, 3, or 5 dogs. Okay, we smashed through that really fast. Anyone got questions? Is that what you all had? What is this, 9, 7, 9? Does that seem like about right? That seems like that's right. Note this next thing. We're doing 2 households. So now we're selecting first one thing, looking at it, recording the result, selecting another household, looking at it, recording the result. And so this word and means we're going to multiply these probabilities together. So the first household, we're looking at having 2 dogs, that's 0.029. The second household having 4 dogs, that's 0.021. So this is the probability that when we pick these 2 houses, the first one had 2, the second one had 4. Turns out the order doesn't particularly matter. 4 decimal places, 1, 2, 3, 4. 0.0019. When multiplying, things have to be independent or the multiplication doesn't work. It isn't true. So there's that. Oh, exactly 1 dog. This is our friend. Remember, we've got an n equal to 2. So we're doing 1 minus the 1 minus 1 dog. So what's the 1 dog? 0.248. And since we're doing 2 of those selections, we're going to square that. And that's our answer on that one. I'm just writing these out because we're running out of time. I wanted you to practice them. It's almost useless to watch me do this unless you've never seen this before. 0.4345. All right, last one. What's the probability at least one household has 3 dogs? What? Okay, so this is wrong because I'm not good at reading. It didn't say at least 1. It says, what is the probability that both households have exactly 1 dog? Whew, did anyone have a different answer there? I hope you did. Did you do 0.24 squared? That's what you should have done. So it's 0.0615. Notice I ran the problem as if it had said exactly, or at least one dog. So here, this is a tricky one. So here's the at least one part. And we're saying that it has at least one of the households has 3 dogs in it. So this is going to be 1 minus the 1 minus not having 3 dogs. Yikes. Well, that's just 1 minus 0.043, right? To get all the other options. So 1 minus 0.043. And because we're selecting 2 of these households, we're going to square that. And this is going to be the result. 0.043. Oh, there's actually dogs in the problem. Oops. 0.0842. Okay. Did you all get those without, oh, it's 1 o'clock. So homework is this one. This is the chapter 5 review worksheet number 2. And on Wednesday or on Monday, you can talk about with Cindy if that's what you want, or Wednesday we can talk about it.
We can do it Monday.
Perfect.
We'll have time Monday. But you guys try it. Don't come with it blank.
We're at the point, y'all, that you've got to do it yourself to know that you've got it. It's great to watch me do it because I better got it. As Laura, you pointed out, I've got that degree, so I better be able to do it. But I'm not taking the exam, so I don't need to practice it. So try it out. Sorry I can't be here Monday. I will be available by email, but you're in good hands and better hands. So go to use the 033 link, and I'm sure we'll both be sending out reminders on Monday where to go. And I will see you all on Wednesday.
I'll see you tonight, Eric.
Yes, tonight. Okay, y'all. Bye.